So how it's made, the overview, very high level, is we make a request to the noaa.gov API. There's a workflow here for getting the training data that produces some training batches just for the past week worth of daily temperatures. There's a little other stuff here, but if people have questions, we can talk about it. That training batch is sent over to the get latest model workflow. What that does is it updates it gets the most up-to-date model and then updates it with the current data that we just got for today. And then it forecasts for, in this case, just a week's worth of forecasts of mean daily temperature, and then some metrics. Those forecasts are then read in by a Streamlit app. Streamlit is, it's like Jupyter notebooks, but a Python script that you can just run, and it renders like an app for you really nicely. So I'll show you what that looks like. Digging in a little bit to the data, how the data works, and I'll just talk through what this is doing. So in the get training data, we're kind of zooming into it and looking at the subtasks, but get training data itself is a dynamic workflow, and it iterates through this for loop of you specify a start date, so you can give it some prior knowledge. So if you start training the data model today, you basically you specify with the start variable here, how much prior knowledge do you want to give it? Do you want to give it a week's worth of training before today, or 3 weeks or a month? So it iterates through here, and this is an interesting thing that I tried, and it's happily it works. But the data that NOAA returns is just a CSV. It's a giant CSV for a particular kind of date range, and so you can compute beforehand whether that CSV file has all the data, or whether it's going to be updated tomorrow with some new weather data. And so here, this branching path, if the data is complete, i.e. there's going to be a new CSV file, and that the current one I'm referencing won't be updated tomorrow or the day after, you can assume that that CSV file is complete, and I'm going to just cache all of the data associated with this particular training instance. If it's not complete, I get a partial training instance, in which case I don't want to cache it, so I'll fetch it again when it's updated tomorrow. That produces a list of training instances, just batch, and that goes into the model. So that's a little fun thing that took a little bit of debugging to get to work, but I'll show you later why I did this. The model is pretty simple. This is also dynamic. I forgot to annotate this, but it just loops through the batches and updates the model for each of those days. Pretty straightforward. This is also cached, so you kind of have cached and tracked versions of all your model updates over time. And for forecasting, it's a similar thing that I'm doing. I'm just iterating from now to however many days I want to forecast for, and I do a similar thing where if I already got that training instance from the training run or a previous training run, then I don't have to recompute and get all this data. And in the case that the data is not complete, I just get a partial instance. And then I create a bunch of forecasts. And for this prototype, I made 3 launch plans, one in Atlanta, which is where I'm at, Seattle, which is where a bunch of the team is, and then Hyderabad. I think I might have missed a few team members, but this is just a fun thing to just localize all of us and get a sense of, I didn't want to do the entire world, so just had to pick some heuristic. And now I'll just want to show you a quick demo. So this is the Streamlit app that there are some issues with the Hyderabad launch plan. So right now there's just Atlanta and Seattle. But as you can see, I haven't really tuned this model very well. It's just producing kind of similar outputs for Atlanta. Seattle, at least regionally, it makes sense. So Seattle, I think the predictions are lower than than Atlanta. So Atlanta is hotter. So like on average, the model is producing kind of sensical behavior, but still it's I haven't looked at the metrics yet, but that said, this app is creating a Flyte client, and it's just reading the latest executions for each of these launch clients. So when the control plane stuff that I'm also working on is completed, the code backing this app will be a lot cleaner. It's kind of, I don't want to show it because it's kind of a rickety house.